This video will cover examples 7 and 8 of section 8.3 Introduction to Probability, and this is for the class Math 1324. So example 7, we have here a regular deck of cards, and so the total of a deck of cards, it's 52. Out of those 52, we have 4 different suits, and those are hearts, clubs, diamonds, and spades, and you can see the shapes here. Now, out of those, for each suit, we have 13 cards in total, and those 13 cards, we have an ace, numbers from 2 all the way to 10, and then we have what we called the face cards, and the face cards will be the Jack, Queen, and King. And by the way, this problem should be helpful with your take-home exam. So here we're going to calculate the probability of getting certain cards if a single card is drawn at random from a standard well shuffle 52 card deck. So remember that when we calculate probability, we need to know the total of the cards, in this case, or of whatever items you're choosing from. So we have 52 for the total. And for the number of aces, it will be 1, 2, 3, and 4. So we have a total of 4. So 4 over 52. And of course we have to simplify, so we can divide 4 divided by 4 is 1. 52 divided by 4 is 13. And so that will be the probability of getting an ace. Now, what is the probability of getting a face card? And so the total in this case will be the same, 52. And we have a total of 3 face cards for each suit. So we'll have 3, 6, 9, and 12. So 12 out of 52. And of course here we can simplify. We could divide by 4 actually. 12 divided by 4 is 3. And 52 divided by 4 is 13. Now for the next part, what is the probability of drawing a spade? And for that, a spade is one of our suits. And so we have here 13 cards with the same suit, spades. So that will be the probability of getting a spade will be 13 out of 52. And of course we can reduce this fraction. 13 divided by 13 is 1, and 52 divided by 13 is 4. Next problem, it says, what is the probability of drawing a spade or a heart? So in this case, because drawing a spade and drawing a heart are mutually exclusive events, they're disjoint events, they have nothing in common, so then we will just have to add the probability of drawing a spade plus the probability of drawing a heart. So for this one, we do not have to subtract the intersection because there is no intersection. The intersection is just 0. So the probability of drawing a spade, it is 13 out of 52. And the probability of drawing a heart is also 13 out of 52 because there are 13 cards with the same suit, a heart. And if we add these two fractions, we will get 26 divided by 52. And of course, we can divide by 2. We'll get 13 divided by 26. And we can divide by 13 now. And so this 13 divided by 13 is 1. 26 divided by 13 is 2. So the probability of you drawing a card and getting a spade or a heart is half, or 0.5. Just like as we discussed in class, for any event, probabilities go from 0 to 1, including 0. That's why we have the equal part, and including 1. Remember, 1 represents 100%. When we did the problem in class about tossing a coin, we had for each event, the probability was 0.5 of getting heads or tails. Now, for other real-life problems, the events in the sample space do not have that equal likely probability. So in those cases, you have to sometimes create tables like the one we have here. And in this case, we have different trials, and also they are testing for some ceramic sinks. And so out of those trials, the frequency for which they were I believe going to break was fluctuating. So you could see it goes from 0, 0.5, 0.33, 0.25, 0.2, it goes back up to 0.33. And so for those types of probabilities, and the way the frequency is estimated, they're sometimes called empirical probabilities. And those require analyzing trials, outcomes, and of course condensing the data, and sometimes they are plot and graphs, such as this one. Now, the last example, it talks about a survey, and the responses were, the question was, do you feel that your standard living is much better, somewhat better, about the same, somewhat worse, much worse than your parents? That was a question. So the total of people who took the survey, if you add all those numbers from the second column, we will obtain 1,932. So that's going to be our total. So to answer the first question here, estimate the probability that a U.S. resident feels his or her standard of living is much better than that of her parents. It will be his or her parents, so much better, we will have 573. So for that, the probability will be 573 divided by the total, which we calculated here by adding 1,932. And so that will give us approximately 0.2966. And for the second question, it says estimate the probability of the event B, and that will be that a U.S. resident feels, based on the survey results, that his or her standard of living is somewhat worse or much worse than the one of their parents. So for that, we will have to add these two numbers. So we have 238 divided by 1932 plus 100 divided by 1932. And of course, you could also write both fractions under the same line. And so we will get that 338 divided by 1932. And so that will be approximately 0.1749. And this concludes the video.